Hey sixth graders, it's Mrs. Hebert. We are going to do a video lesson for lesson 4.1, which is module 4, lesson 1, and that will be about fraction operations. And the pages in your notebook should be pages 15 and 16. We're going to be taking notes on page 15 as you watch the video. So on your table of contents, page 1, go ahead and add this lesson to your table of contents, just like I have here at the bottom. Okay, to start off with, put the heading 4.1 fraction operations at the top of page 15, and then you're going to create 3 sections instead of 6 this time. And the first section needs to be your largest section. I would go down about halfway, at least halfway down, and create one line across so that you have one wide area to take notes in section 1. Then I would divide section 2 and section 3 in the bottom half of the page, and just divide it. Maybe give yourself a little more room for section 3, maybe an extra line than you do for section 2. But something like this. You can always erase it and adjust if you need to. Okay, starting in section 1, and remember that your section 1 is not the whole page. I just have the whole page because of my stylus. But in section 1, you're going to write the notes that I have here. So you're going to write section 1, 1 with a circle, and then adding and subtracting fractions, and then underline it. And then you're going to have 2 parts to this, 2 sides. There's an A side and a B side. So the A side is what we do when we have like denominators. That means when our denominators are the same. When we're adding and subtracting fractions and the denominator, which is the bottom number in a fraction, are the same. So the first thing you do, next to number 1, you would write, after you write like denominators, put a number 1, and then write add or subtract the numerators. And then step 2 is to place them over the common denominator. So for example, like I have here on this page, 3/5 plus 1/5. Because the denominators are the same, they're both 5, it's easy to add or subtract this fraction, these fractions. Because all you have to do is add the numerators, 3 plus 1 equals 4, and then put the numerator over the common denominator, which is 5. So 3/5 plus 1/5 equals 4/5. Easy. For subtraction, it works the same way, as long as the denominators are the same. So if I have 3/5 minus 1/5, I'm going to subtract the numerators this time. So 3 minus 1 equals 2. And then I'm going to put that numerator over the common denominator, which is 5 in this case. So when you have fractions, when you're adding and subtracting fractions that have already have a common denominator or the same denominator. Okay, when you get to unlike denominators, however, you have to add an extra step. So for section B on the other side, you're going to write unlike denominators. And then we're going to write down some notes for the procedure for unlike denominators. So the first thing you have to do is find the least common denominator for the fractions you're working with. The least common denominator is really the same thing as the least common multiple of your denominators. And we'll talk about that in just a minute. But go ahead and write that down. Find the LCD, and you can put in parentheses that it's the same thing as the LCM if you want to. So after you find the least common denominator, the second step is to multiply to create fractions with a common denominator. And I'm going to show you how to do that in just a minute, but go ahead and take the notes. So multiply to create fractions that have a common denominator. Then for step 3, you're going to add or subtract the numerators. Okay. And so then, I'm sorry, I got interrupted, so hopefully I'm not repeating myself. But after you multiply to create fractions with a common denominator, the third step is to add or subtract the numerators, whichever you're doing, and then you're going to place that numerator over the common denominator like you did before. So the example here, and I'm going to be writing big, but you need to fit this all in to that first section on your paper. But the first example I have is 3/5 plus 2/6. Well, 3/5 has a different denominator than 2/6. So my denominators are 5 and 6. So I have to try to find the least common denominator or the least common multiple of 5 and 6. And if I do that, I believe that the least common multiple, which is also the least common denominator, is going to be 30. And so I have to create equivalent fractions that have a denominator of 30. So what I'm going to do is I'm going to take 3/5 and 2/6, and I'm adding those. And then I am going to create denominators of 30 by multiplying the denominators by another factor that will give me 30. So I say to myself, 5 times what gives me 30? Well, in this case, 5 times 6. And remember that dot is a sign for multiplication. So 5 times 6 will give me a denominator of 30. But whatever I do to the denominator, I must do to the numerator. So I also have to multiply on that fraction only the numerator by 6. So I multiplied the 5 by 6 to give myself 30, and the 3 by 6, which will give me 18. So that gives me 3/5. An equivalent fraction for 3/5 will be 18/30. And I know it's a little bit hard to see in the blue, but I'm trying to show you the different steps. Okay, then I'm going to add, and I'm going to do the next fraction separately. I still need to get a common denominator of 30. So I say 6 times what will give me 30. So it's 6 times 5 gives me 30. And whatever I do to the denominator, I must do to the numerator. So I'm going to multiply the numerator times 5. That gives me 10/30. So I know it's a little bit hard to see. I wish I had other colors. But I basically have 18/30 plus 10/30 because 18/30 is equal to 3/5 and 10/30 is equal to 2/6. Then, now that my denominators are the same, it's easy because all I have to do is I have to add my numerators. So 18 plus 10 is 28. And put that over my common denominator of 30. And I get 28/30. Now, there's just one more step, and you probably already know what it is, but I need to simplify this fraction because really I need to put it in simplest form. So I say 28/30, and I know they're both divisible for sure by 2. I don't think they're divisible by anything else, but I'll know when I try this out. So 28 divided by 2 gives me 14. And 30 divided by 2 will give me 15. And 14/15 is in simplest form because there is nothing that will go into 14 and 15. So 14/15 is my answer. Okay, now go down to box number 2 and write these notes in. We're going to talk about multiplying fractions. Okay, multiplying fractions is really very, very easy. All you have to do is first multiply the numerators, and then second multiply the denominators, and then simplify. I don't have simplify there as a step. I probably should have put that in there, but you can add that in there if you want. But normally you'll get a fraction, and if it's not in simplest form, you would simplify it anyway. So, for example, if I have 1/3 times 3/5, I'm going to multiply my numerators. In this case, it's 1 times 3, which is 3. I'm going to put that over 3 times 5, which is 15. So 1/3 times 3/5 equals 3/15. Pretty easy. However, I have to simplify. So 3 and 15 are both divisible by 3. And again, I'm sorry, my ink is not a darker color. But 3 divided by 3 gives me 1. And 15 divided by 3 gives me 5. 1/5 is in simplest form because there's nothing that goes into 1 and 5. Okay? Now, there is a trick when you get more complicated fractions, when you get bigger numbers. You can still multiply them the same way. You can say, for example, 3/7 times 2/3, and you can multiply the numerators and get 3 times 2 equals 6 over 7 times 3, which is 21, and then you can reduce. They're both divisible by 3. And that gives you 2 over 7, because 6 divided by 3 is 2, and 21 divided by 3 is 7. That's in simplest form. However, there is a trick, which I show right here. This trick, or I explain. You can simplify before you multiply by using what we call the cross-reduce method. Some people call it cross-canceling. And here's how you do it. I'm going to put it in black. I'm going to take 3/7 times 2/3, and I'm going to look diagonally. So I'm going to look at this 3 and this 3 because they're diagonal from each other. And so I look across from fraction to fraction diagonally, and I say, is there anything that will go into 3 and 3? And yes, there is. 3 goes into 3 and 3, and it goes in one time. So I can go ahead and reduce. Okay, so 3 divided by 3 is 1, so I cross out the 3 and put a 1 there. And this 3 divided by 3 is a 1, so I cross out that 3, and that becomes 1. Now, I could also do it the other way if I was able to. I could look and I could say, is there anything that goes into 2 and 7? But in this case, there isn't, so I can't cross multiply this other direction that I've highlighted with blue a little bit. There's nothing that will go into 2 and 7. So I can't cross cancel or cross reduce. So I'm just going to go ahead and solve it the way it is. And so now instead of 3 times 2, I have 1 times 2, which is 2. And I have 7 times 1, which is 7. And I get 2/7. If you compare the answers, they are the same. Okay? So you just have to figure out what's easier for you. When the fractions are fairly simple, like this one's fairly simple, 3/7 times 2/3, it's easy to just multiply and then reduce. But when your fractions get bigger and your answers get bigger and it gets harder to reduce, the cross-reduce method or cross-canceling method where you reduce before you multiply can really save you a lot of work. So it's a neat little trick. Okay, we're going to do some examples now in the third section, and you're just going to have to try to squeeze these in, and I know it's not going to be the easiest thing. So I tried to mix it up a little bit by giving you a little bit harder examples here than what we did in the lesson. So for example 1, we're going to add 2 fractions, but in this case I have a fraction plus a mixed number. Well, it's really the same rules apply for adding fractions, regardless of whether you have a regular fraction or a mixed fraction, because all you're going to do is turn that mixed fraction into an improper fraction, and then you'll be able to add like you normally would. So 2/3 plus 6 1/5 becomes 2/3 plus 5 times 6 is 30, because I multiplied my denominator by my whole number. So 5 times 6 is 30, and then I add my numerator, which is 31. So that gives me 31 over 5. Now, I have to get a common denominator. So I say, okay, what is my least common denominator for 3 and 5, or my least common multiple? And in this case, the least common multiple is 15. So I need to get common denominator of 15. The way I do that is by multiplying each denominator by a factor that will give me 15. So 3 times 5, and then whatever I do to the denominator, I must do to the numerator, so I multiply 2 times 5, and that now becomes 10 over 15, or 10/15. Then I'm going to add it to the next fraction. So 31/5, I need to get the 5 to a 15, so I'm going to multiply that by 3. And whatever I do to the denominator, I do to the numerator. So 31 times 3 is 93. And that's going to go over 15. And I should have an improper fraction still, because I had an improper fraction before. Okay, now I have 10/5 plus 10/15 plus 93/15. Now my denominators are the same. Now it's easy. All I have to do is add the numerators. So 10 plus 93 is 103. And I put it over the common denominator, which is 15. And then I have to simplify. And so if I simplify, 15 goes in, I believe I get 15 will go into 103 6 times. And if I'm not mistaken. Okay, yes. So 15 will go into 103 6 times with 13 left over, because 15 times 6 is 90. And so I have 13 left over. So 6 and 13/15 is my answer in simplest form. Okay, let's look at example 2. I really should have given myself more room. But it's subtracting fractions. So this time I don't have to convert anything into, any mixed numbers into improper fractions. So I'm just going to go ahead and try to find a common denominator. And hopefully it's easiest if I find a least common denominator, but if I find a common one, it will work anyway, as long as I reduce at the end. So I have 9/10 minus 3/14. So I'm going to change, I need to get 10 and 14 to the same denominator. And so when I think in my head, what number would 10 and 14 go into? I could work it out and find their least common multiple, but I'm just going to go with, I'll go with 70, because 10 and 14 will both go into 70. So the first thing I'm going to do is multiply the 10 times a 7 to get 70, which means I have to multiply 9 by 7. So I'm going to get 63/70. 9/10 becomes 63/70. Then I'm going to subtract, and I multiply 14 times 5 to give me 70. And so I must do the same to the numerator. So 3 times 5 gives me 15. So 3/14 becomes 15/70. So my new problem with common denominators is 63/70 minus 15/70. Now that my numerator is the same, my denominators are the same, all I have to do is subtract the numerators. So 63 minus 15 is 48. Then I put that over the common denominator of 70, and that's my answer. However, I'm not done, because it's not in simplest form. So I'm going to put it in simplest form. 48/70. I can definitely divide them by 2. I may be able to reduce them even more, but I'm going to start with dividing by 2. So 48 divided by 2 is 24. 70 divided by 2 is 35. Is there anything that will go into 24 and 35? No, because 35 is only going to be divisible by numbers that have, really by 5s. So 24/35 is in simplest form. And I'm done. Okay, looking at example 3 now. Here is a mixed number. I'm going to do a multiplication problem now. So this time I gave you a mixed number times a whole number. But it's no different really. You just have to add an extra step, and then you can multiply like we did before. So the first thing you're going to do is change the mixed number to an improper fraction by multiplying the denominator times the whole number. So 8 times 2 is 16, and then you're going to add the numerator, which is 16 plus 3 is 19. So 2 and 3/8 is going to become 19/8. Then you're going to multiply it. And instead of multiplying it by 16, we'll call that 16 over 1, just to make it easy, because 16 over 1 is the same thing as 16. And now I can multiply. I can multiply the numerators and I can multiply the denominators. However, this is where cross reducing can come in handy, because I can do 19 times 16. I can multiply that out. If I were to multiply this out, I would get 19 times 16 is 304. And I would put that over 8 times 1, which is 8. Then I would simplify. 304 divided by 8. 8 goes into 304 38 times evenly. You would have to do the multiplication to know that, most likely. But that would work. However, there's an easier way without having to do all the multiplication and division, and that is to take 19/8 times 16 over 1 and cross reduce. So I'm going to go diagonally. I notice that the 8 and the 16 are both divisible by 8. So 8 divided by 8 is 1. 1. And 16 divided by 8 is 2. So I reduced those. Instead of 8 and 16, it's 1 and 2, because 16 is twice that of 8. So now that I have that, I can just say 19 times 2, which is 38. And 1 times 1 is 1. So 38 over 1 equals 38. And these are the same. So I'm going to go over them with black so you can see them now. 38 and 38 are the same. Okay, so I like to use the cross-reducing method when I have bigger numbers. It just makes the multiplication and division easier. But you can do it either way. Okay, when you finish, this is something like what your paper should look like. Maybe not exactly, but something like it. And I apologize that it's a little blurry. The picture I took was a little blurry. I do have one mistake here, though. In box 3, this should really be 6 and 13/15 instead of 6 and 3/15 because of that answer. So just check your answers there. Otherwise, I think we're pretty good. So that should be similar. Your page should look similar to mine. And then we're done. Well done.